Imagine building the world's tallest tower on soil that is more like quicksand than bedrock. One wrong move, and it could sink like a stone. Enter the piled raft foundation, a smart engineering mashup of deep piles and a wide raft slab that turns unstable ground into a rock-solid base. Today, we'll explore how these two systems integrate to support megastructures. Stick around to see why it is a game changer in civil engineering. Let's break it down. A pile foundation is like the roots of a skyscraper. These long, slender columns made of concrete, steel, or timber drive deep into the earth, transferring massive loads from the building to stable layers far below. They're essential in soft or weak soils where surface bearing isn't enough. On the flip side, a raft foundation or mat foundation is a thick, reinforced concrete slab that floats across the entire building footprint. It spreads the load evenly over a wide area, reducing pressure on the soil, like lying on a bed of nails instead of standing on one. Alone, they're great, but together, that is where the magic happens. Here is a side-by-side comparison. Why bother integrating piles and rafts? Simple efficiency. A standalone raft might settle too much under heavy loads, cracking your building. Piles alone require hundreds for uniform support, jacking up costs. The piled raft shares the load. Piles handle 50 to 80% of the weight, reducing settlement by up to 75%, while the raft distributes the rest evenly, boosting overall capacity. This hybrid cuts material use by 20 to 40%, saves time, and minimizes differential settlement, that uneven sinking that warps structures. Plus, it is versatile for challenging sites, compressible clays, urban fill, or seismic zones. In essence, integration turns weaknesses into strengths. Piles add depth, the raft adds breadth. So, how do they come together? It is a three-part symphony: piles, raft, and soil. Piles first, strategically placed, fewer than in pure pile systems. Say 20 to 50 F or a high-rise. Piles are bored or driven to reach firm strata. They resist via skin friction, gripping soil sides or end-bearing tip on rock. Raft integration. A reinforced concrete slab 0.5-2 m thick is cast directly over the piles, embedding their heads. This creates a rigid cap, no gaps, full connectivity. In advanced disconnected variants, a compressible cushion like gravel or foam sits between for extra settlement control. Load transfer magic under building weight. The raft flexes slightly, channeling heavy corner loads to piles while spreading lighter ones across the soil. Finite element modeling, like Plaxis software, simulates this, factoring in soil-pile-raft interactions for precise pile spacing and raft thickness. This isn't theory, it is proven. The Burj Khalifa in Dubai integrates 194 megapiles under a 5 m thick raft, handling 500,000 tons with just 40 millimeters settlement. Frankfurt's Messeturm used a piled raft to bridge a street below, saving millions. Challenges. Variable soils demand site-specific tests, and seismic zones need extra damping. But with tools like 3D modeling, it is safer and greener than ever. Piled raft integration isn't just smart, it is essential for tomorrow's cities. From reducing costs to conquering tricky soils, it is engineering evolution in action. What is your next build on? Drop a comment below, like, share, and subscribe for more deep dives into foundations. Thanks for watching.